Alrighty. I think this is probably when I did it on a contest. But anyways, let's see if I can do it again. Using a robot to print the lexicographically smallest string. Lots of lexicographically deals recently. Right, you're given a string S in a robot that currently holds an empty string. Apply one of the following operations until S and T are both empty. You're given a string S and a robot that currently holds an empty string. Okay. Remove the first character of the string S and give it to the robot. Give it to the robot. The robot will append its character string T. Remove the last character of string T and give it to the robot. The robot will write this character on paper. Return the lexicographically small string that can be written on paper. Oh boy. Kind of a vague memory of this being like really long for me to figure out the first time. Return the lexicographically small string that can be written on paper. So ZZA output would be AZZ. So there's like two buckets, the starting bucket and a robot bucket. Remove the first character of the starting bucket, append it to the string T at the end. Remove the last character of string T and give it to the robot. So the first bucket you can only remove the starting stuff, and the other bucket you can it's a stack, and you can only remove the last character. The robot will append the character's strings. So remove the stuff from the start of S, you add it to the end of T, you move it from the end of T, and you give it to the robot. Okay, so ZZA becomes AZZ. So you have to go ZZA in that order. So you have to move from S in that order ZZA. But between those moves, can take the last character of the second bucket. So you'd move Z, you move Z, then you move A, and then you take out A, you take out Z, you take out Z. Okay. And then this one, you move B, move A, take out the A, you take out the B, and then you move C. Yeah, so perform the first move operation twice, and then do the, so I think maybe I think I'll say the first operation is a move operation, or yeah, I'll say the first two are move operations and then the second two are pop operations. So you move twice, so that gives you BA in the second one, and then you pop twice in the second one, so popping would make it AB in the final one, and then you do a move pop. Move twice, pop twice, move pop. Here would be move 4 times, because you want A to be the last thing, and then pop all 4 times. Oh boy. Okay. I think I have trauma from trying to do this before. Like it took me so long. And I really did not recall how to do it. So what is feasible here? You move so somehow you need to have the lowest character moved, right? or the lowest character will always be popped. So the lowest character will always be popped. I think you probably need to do this in, yeah, this 10 to the 5th, you probably need to do this in linear time. Possibly sorted, so possibly n log n, but likely linear. 10 to the 5th, if it's quadratic time, then it'd be like 10 to the 10th, which is too slow. If you were to sort it, I don't see how sorting it would necessarily work. So for instance here, if I were to sort it, it becomes A, B, D, D. And it's not like I can get A, B in the actual ending string. So even though I can guarantee that I have the lowest character as the start of my output, it's anything after that might be in kind of unsorted fashion. If my quick analysis here could be wrong. So for any given string, is it possible that the string will start with just the lowest character? So if there's multiple A's, let's say there's 3 A's in the string, is it guaranteed that I will have 3 A's in the output? I don't think so. I could be wrong. So let's say the example string is B, E, A, B, B, A, and then C, A. So move, move, pop, move, move, pop, move, move, pop. Or it's at move, move, A's at the ending, so pop the A. Move, 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 pop. Move, 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 pop. So the A's do guarantee to be at the end. And then what? So actually let's do a test case here. B, A, B, B, A, C, C, A. Maybe it is guaranteed that at the very least the A's, the lowest thing starts it. Yeah, lowest thing is then if there are other lows, then you keep on moving and then popping, right? Moving to that next low and then popping. Okay, so how do you know that you should keep on moving? So if you move, move, you have to pretty much go all the way to the end, right? In order to know that there's the low. Pretty much have to go all the way to the end. You could also sort it and then figure out what your lowest values are and then see if there's another low value in there. So for instance, if I know at any given time what my low value is, and if the low value is already seen, let's see, let's say I actually do have some sort of sorted version of the input. I push AA. I know that A is the lowest, and maybe I know that there's 3 A's in there. Then I know that I can and probably I can and probably should immediately pop. Yep. And then I keep on pushing until I see the second one, and I keep on pushing until I see the third one, and keep on seeing. So I'd do move, move, pop, move, 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 pop. And because I know that there's a smaller one still out there, I need to move to that next smallest one and pop. So that's one. So that would work for getting rid of the very lowest. And then secondly, if I know that the second smallest is B, I know that the second smallest is B, then I either, so if at the moment that I pop the lowest one, if at the moment I pop the lowest one, let's say F, G, B. So I move, move, pop, move, move, pop, move, move, pop. So I get 3 A's in a thing, and like B, B, D, C, C is what remains in the second bucket. I know that there's another B coming up, and I know that there's some B's behind. So if I were to pop right now, there'd be a C. If I were to move forward, I can get the next B. So I know that I need to move forward to get the next B. So B, F, G, move, 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 move. Now I could pop immediately to get this B, but then, yeah, if it's a small value, then you should pop. You always take off the top. Always take off the top if possible, but otherwise, if the smallest value is still to come, then you should take it from the future. Is there a way I can actually work that? Is there a way I can actually keep track of that? Okay, so let's say I have a data structure to hold I'll call it buckets. So it all starts in bucket 1, and then it moves to bucket 2, and then the robot is the final bucket. I guess I can call bucket 2 a stack. I guess I can also say the starting thing is it's an array, right? So I have an index, and I'll say my middle my string t is in a queue, no, stack. So I'll say stack for that one. And my answer is going to be something. So first I want to figure out the sorting of it. Where do I want to counter? Maybe I want counts of everything, and maybe I want a sorted version of it. Where do I want a heap to keep track of this next sorted value, next smallest sorted thing? Fortunately, if I were to move down the chain, the heap doesn't necessarily keep track of removables. What if at any given point I determine, or get any given index in the string, I determine the index later on of a character that is smaller than it, if possible. So for instance, A, maybe I can say, so the B here, the next thing that's smallest would be this thing. And the A thing, the next thing that's smallest would be this B. So that if I know at any given point what the smallest remaining is, then I know whether or not I need to pop or whether I need to keep on adding to the middle bucket. The smallest remaining one, so it needs to be both the index of the smallest. Does it need to be index? Does it need to just be the size of the thing? Okay, I am going to start by converting this thing into integers. Does that make sense? Maybe converting integers is just too hard to me figure out what the translation is, actually. So let's say I have a remaining array, which is the same size, and I'll say I do need to know what the value that's the smallest remaining value is for each index. Track the smallest value after that. So for instance, for index 0, the smallest value would be A. For index A, the smallest value would be another A. For index A, here another value, the smallest value would be B. So I think maybe, how would I do it? I think I do a backwards loop. So for every index in the range of the end to the front, and -1 to the front. Oh, this should be the size of the thing. So this is maybe I'll put -1 times n. It should set it for everything. There shouldn't be a -1 at any spot, but well, at the final spot, what is it going to be? I guess maybe it is -1 at the final spot. So actually I don't know what I'd put for the last one after this final B, lowest value would be. Maybe I need to actually make that minus 2. Okay, so let's say I keep track of the current lowest, and that's going to be B. And let's say, okay, let's keep track of the lowest, going to be B. So the low here should be unknown for the last one, and then B, 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 here would be A, A. Everything after for this A is going to have A. Okay. So the current is going to be, maybe I can start the lowest Z. Maybe that's fine. The current value is going to be, well, no, I think I start by saying remain of the low, remain of the current index is the low, remain of the current index is the low, and then I do the update. If the current value at this index, which is set this index, is less than the low, then the low is equal to this value, and then I move forward. Okay, let's go ahead and print out what that looks like. Yeah, that's correct. So the low after this is A, low after this is another A, low after this A is actually a B, 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 and low after this is like a Z. Z is kind of a dummy low. It's A, A, A. So that might work to deduce whether or not I need to push forward or I need to pop immediately or move. Maybe I need to know what the low is before any given index as well. Interesting. Okay, so let's try something here. So for every index in range n, where the index is iterating through the initial string, I'm going to say if so I will generally want to pop only if I know that the current thing is the low. So if the stack exists and the top of the stack, the last thing on the stack, last thing on the stack is the last element of the stack, is equal to the low that remains. The low that remains from this index. Now I guess this is a while loop. While there's stuff in the middle stack, and again this middle stack is what I'm going to call the second bucket, string t. While that exists and that middle bucket has on top of it something that is equal to the lowest remaining value, which is remain index, then I will say answer.append stack.pop. Okay. Otherwise, what? So you'll pop a bunch of A's at the lowest thing is an A. Otherwise, it should once it does that, then it should push onto the stack, move the stuff from the string S2, which in this case is just saying stack.append the current element in the string index of S. I'm missing a few cases here. This is always going to be true, but what happens in the more general case? So what happened here? It would say stack is empty for the first loop, and it would be onto the stack. And then B is not the lowest, so it doesn't move anything, doesn't pop anything. Then it says it moves A, and A is onto the stack. At that point, A is the top of the stack, and A is the lowest. So A is popped. And then it moves another B, so BB. And then next time, B is not the lowest, so then it just moves D. So it moves, now stack is BBD. Next time, it moves A. Next time, it sees A is the top, which is the lowest remaining, so it pops A. And then it moves to C. And then moves another C. And then moves an A. And it pops the A, then moves F. And then moves the G. Moves the B. Moves the B. At that point, what happens? The index is at n. Well, if there's nothing left, then you just have to call it a day. So at this point, it should be while there's a stack, then answer.append stack.pop. So it needs to just move stuff from the stack to the answer. Okay, so that's kind of simple casework. It needs to also what happens I wonder. Return the answer. Didn't work. Oops. Oh, this thing didn't work correctly. AABG. Huh. Okay. If the stack. Oh, whoops. If the stack and the top of the stack is smaller than the thing, less than or equal to. AAA. So at least I got 3 A's there. Now why did it pop out the G? When it sees the B, when it sees the B, the lowest remaining is Z. It pops out the G. I see. So maybe I should be setting my lowest remaining to be, well, it doesn't make sense to set it to be initially A, because then it'd always be A. So when it sees the G, maybe it makes sense to set the lowest remaining to be equal to the last thing. The low is equal to the last thing in the string. A, B, G, F, C, C, D, D, B. Okay. A, D, D, B. No, this didn't work. Okay, so why didn't this work? So it moved the B, moved the A, should pop the, didn't pop the A. It didn't pop the A. Really? So it moved the, okay, I need to know what the actual low values that it determined was. Oops, it should be remain. Okay. ACC. So after the A, the lowest is C. Okay, sure, yeah. So it should move the, it should move the B, should move the A. At that point, it should compare A to C, no? A is smaller than or equal to C. A smaller than C, it should be. While stack and stack, top of the stack is smaller than or equal to the remaining smallest index. So when the index is 2, the smallest compare A to C, and this should be true. So should pop the A. Oh. Well, compared the B to the C. I see. Right, so when there's the A's, before A is actually moved, it compares this B to the remaining lows, see? But A is actually lower than both. So how should that work? Maybe it's the timing is wrong. Maybe it should include the current value as the remaining as it should include the current value in its calculation as to what is the remaining low value. So it should be something like, yeah, this should be reversed. If the current value is smaller than low value, then set it to the B, update the current low value, and then set the remain. Yeah, okay. Guess that's pretty consistent actually. Okay, now this, okay, it's ABC, AZZ, ADDB, AA, BG, FCC, DBB. Okay, so let's try and turn the join of the answer. Okay, remove the prints. Oh my god. Holy cow. That was so much shorter than the last time I had to do this. Oh my god. Okay. I knew I was stumped for this for like hours, if not multiple sessions. Index, I can get rid of. Stack, I need keep. Answer, keep. I never use counter. Length, remain low. Okay. That might actually have improved it because I didn't have a counter this last pass. Okay. Just as curiosity's sake, I'm actually going to look at the, what did I submit so many months ago? August. Something that was slower. Guess this was the fastest that I submitted. 147 seconds. Which is faster than my current time actually. 255. My current time has somehow improved compared to all the submissions. Okay, so anyways, it was the submission. Huh, I actually coded this with the... did I... Oh, this is in Java, no wonder it's faster. Okay. Yeah, the Python version was actually... Python version was... I did this multiple times. Okay, let's see comparatively what I did. I have an increasing stat. Oh yeah, I had multiple stacks. I have a prior stack. Oh boy, yeah. I'm gonna say this is probably a better solution. Sometimes you luck into the correct way of, or a faster way of thinking. Just give enough months to forget the previous way of thinking. So here, summary is the key idea is at any given point. Okay, so in general, the options are, and I'll just rephrase it, move. This is from bucket 1 to from move first character from string s. And then 2 is to move it from string s to a stack, to a kind of middle temp stack. and then 2 is to pop from stack to answer string. And the key idea is only pop from answer if the character popped is smaller than all remaining characters in string S. So if you have a string that is, let's say your lowest values for your A's, right? Let's say it's a bunch of letters in A, and then a bunch of other letters that are not A, another A, and a bunch more letters, and then so there's these A's here, and you can never pop from your middle until you have kind of moved everything to get to the A's and then pop the A's. Move everything to the next A and pop the A. So eventually your answer string should have the A's as your starting point. There's no other. It's always going to be best to have those A's as your starting ones rather than any other string lexicographically small. So next idea is to, for each index in string S, determine what the smallest remaining value is. So you know if you need to move more or can pop. So if your smallest is your A's, and let's say from here it's this B is the next smallest one, right? So you've done your A's, and now you need to know what you're looking for. Are you looking for something that is smaller than the O, kind of? Because at this stage, O is in your stack. And if you know that from this point on, well, actually after you pop the A, it's gonna be Q is gonna be kind of the next thing. But from the Q on, there's a future B that's good, and it's gonna be smaller than the Q or the O currently. So therefore, you need to keep on moving down towards the B. So basically, so track the smallest. So basically, I create an array. I called it remain, which includes the smallest character from this index on. And then at any time pop from stack if the top of stack is smaller than or equal to smallest remaining. So for instance, if my smallest remaining here after the A is like a D, but the stack already has like a CC and a B, right? Then I should pop these things off the stack. And then once I can't do that anymore, keep on moving down until I get to D. So that was the stuff here. First is creating the remaining array for each index going backwards, assuming that my smallest remaining is going to be just my last character if I'm dealing with the last index. I update, compare it to the current index character, and then assign into the array at this index what that low value is, and then iterating through all the indices of the string, if the stack has a smaller value at its top than anything that remains from this index on. Keep on popping, and then just move the current character onto the stack. And then finally, lastly, once all indices have been moved, which is done through the for loop, any stack needs to be added to the needs to be popped to the answer. So just pop every character in the stack to the answer. All right, time complexity is definitely O of n to create the remaining array, and to iterate through the string moving / popping. And you can only move each character once, and you can only pop each character once. So it's all linear to the number of elements in your string, where n is the length of string s. With base complexity, this is also O of n to create the remain array, which is size n, and the answer is not included with that.